Hello everyone, welcome to the third video lecture on circuit analysis 1. In the last session, we have seen the potential difference and the electric power, how we can determine potential difference, voltage or electromotive force, as well as the electric power. Okay, electric power. Today we'll continue from the previous one. So we have seen that the electric power, we can calculate the electric power by using different techniques. The first one is voltage times, that power which is given by voltage times current, or power which is given by dW by dt. Okay, so let's continue from the previous one. The first method, what we have seen in the last session, is we use the defining equation as follows, which is voltage times current. That means this is a passive sign convention. Okay, the passive sign convention. So, basically, for this case, you can consider power which is given by V times current. This is for the passive sign convention. That means when the current is entering the positive terminal and leaving the negative terminal, power will be given by this expression. Okay, that is the power, the passive sign convention. Otherwise, we introduce a minus sign. That means this is to mean that when the power is absorbed by an element, when the power is supplied by the element, we need to introduce a negative sign. That means, as you can see here, the current is entering the negative terminal and leaving the positive terminal. So for this case, power will be given by negative voltage times current, negative voltage times. So for this case, you can consider we need to introduce a negative sign. So for the second method, we use the passive sign convention, but in other way, we can express the voltage by using current times resistor. We know that voltage is given by current times resistor. So you can substitute. That means P, which is equals to VI, which is equals to I times R times I, which is I square R. Okay. So for the non-passive sign convention, we need to introduce a negative sign as usual. Okay, if the current is entering the negative terminal and leaving the positive terminal, so power will be negative. That means the power is supplied from a certain circuit element, so it can be the source. So the voltage is given by, for this case, it is given by negative IR. So the power will be R times I squared. So the third method, we express the power at the terminal for resistor in terms of the voltage and resistors as follows. This is the passive sign convention. So you can consider, that means current can be expressed voltage over R. So that from this P, which is equals to VI, so which is V times V over R, V square over. So using this, we can determine also the power using voltage and resistor using current, and resistor using voltage, and current can be used for the determination of power. For the non-passive sign convention, as usual, the current entering the negative terminal and leaving the positive terminal. So you need to introduce a negative sign, so that using this, we can have the power supplied by the element to the load or the other circuit elements in the circuit. Okay. The fourth method, we express the power at the terminals of a resistor in terms of the voltage or current and conductance. We know that conductance, it is given by 1 over R, the inverse of resistor. Okay, the inverse of resistor. So we have this T, which is given by using passive sign convention, which is given by V times I. So we know that I, it is given by V over R. So we know that 1 over R times V, and this one is the conductance. So we can substitute the conductance using this expression, okay? So you'll have this conductance times voltage square will give you the power. This is using passive sign convention. Or inversely, you can express the voltage. You can express the voltage, okay? The voltage. That means V, which is equal to I times R, I times R. So from this we can have I, which is equals to conductance times voltage. So from this, voltage can be expressed by using I over G. So we can substitute the voltage using this expression so that you will have the power, which is current square by conductance, So for the passive sign convention, we'll have identical relation as the passive sign convention. So basically, we need to introduce negative sign so that finally you have a positive expression. So one thing you need to consider here is if the power has negative sign, so that means if the power has negative sign, so power is being supplied by the circuit element. So that means most of the time when the source is supplying power to the load, so the power supplied by the source is negative. If the power has a positive sign, that will indicate that power is being absorbed by any element in the circuit. That means if the calculated power is positive, power is being absorbed by elements of the circuit. So by introducing a negative sign and a positive sign, we can say that power is supplied or power is absorbed by elements of the circuit. The fifth parameter for electrical circuit is the energy. It is the capacity to work, which is measured in joules, basically. So we know that power that is given by dW by dt. So you can multiply by dt for both sides. So P dt, which is equal to dW. So we can take integration both sides, dW, which is equal to the integral T naught by T, which is P dt. So this is how we can determine the energy. Which is 0 up to T, T of T by dt. So we can, if the power expression is given, so we can determine the energy absorbed or the energy transfer from the source to the load. If you have the power expression for a certain time interval, okay? So that's how we can determine the energy transfer from the source to the load. So for this case, find the power absorbed by a circuit element at t is equals to 3 milliseconds if the current entering its positive terminal of a circuit element is given by 5 cos 60 pi t ampere, and the voltage is given by this expression. Okay. So now let's consider we are asked to determine the power absorbed by a circuit element at t is equals to 3 milliseconds. Okay. So the current is entering its positive terminal. The current is entering its positive terminal. To mean that power is positive because it's entering the positive terminal. And we have given that I, which is equals to 5 cos 60 pi t, okay, ampere. And V is given by, which is 3I. So you'll have 3 times I is given 5 cos 60 pi t. So V should be given by 50 cos 60 pi t. Okay? So what should be the power? Power should be V of t I of t. Okay? From this, P of t, which is equals to 5 times 50 times cos square, sorry, cos square 100, 60 pi t. So you have 75 cos square 60 pi t. So we can, at t is equals to 3 milliseconds, we can determine the value of the power at t is equals to 3 seconds. Okay, so that's how we can determine the power if you have the expression for current and voltage. For the second question, first we need to determine V, which is 3 di by dt, so that after that we can multiply by current, so that you have the power expression. Okay. So that's how we can determine. When we come to types of circuit elements, we have two types of circuit elements. Basically, we have two types of circuit elements. The first one is the passive circuit element, and the second one is active circuit elements. For this case, the elements cannot generate their own energy by themselves. Rather, either they store energy or dissipate energy in the element. Okay, so we can consider the passive elements. The most important examples are the 3-1, which is resistor, capacitor, and inductor. So a resistor, when we consider a resistor, dissipate energy in the form of heat, capacitor store energy, which is electric field, and inductor, it will store energy in its magnetic field, but they do not have the capacity to generate energy. When you come to active circuit elements, they can generate their own energy by themselves. We can consider voltage source, current source, battery, operational amplifier, generator. So these elements of circuit can generate their own energy. That is the difference between passive circuit element and active circuit elements. Okay. When you come to the sources, we have the most important active elements of a circuit are voltage and current sources. That means we are going to use voltage source and current source that deliver energy to the circuit connected to them. Okay, so the voltage source can be connected to the circuit so that it will generate energy or deliver energy to the circuit, or current source can also deliver energy to the circuit. So there are two types of sources, basically the dependent sources and the independent sources and the dependent sources. Okay, so when you come to the independent sources, this is an active element of a circuit, provides a specified voltage or current that is completely independent of the other circuit elements. Okay, most of the time the symbol used is a small circle. Okay, small circle with voltage polarity or current direction. Okay, so the symbol used is a small circle with voltage polarity or current direction indicated inside the circle as shown below. Okay, so this is the independent voltage source. So plus, minus, this is the polarity indication. So this is the ideal independent voltage source, or you can consider also the battery. Okay, this is V and this one is V. Okay, so independent voltage sources. When it comes to independent current sources, there is a small circle here. So there is inside the circle there should be current direction. So the current direction should be always directed the positive terminal of the voltage source. Okay, so this is ideal. This is ideal current source. This is ideal current source, which is independent current source. Independent current source. Okay, independent current source. So this, when you face such type of symbols, that means this is independent current source. Independent current source. That means it's independent of the other circuit elements. Other circuit elements. For example, if you consider this voltage source, which is 5 volt. Okay, so if you have such circuit, this is R1, this is R2. So here is current I. So this is an independent voltage source. So this voltage source is independent of this current. Okay, it is independent of this current, and also it is independent of this V1 and is independent of this V2. Okay, so V1 will not affect the 5 volt independent voltage source. V2 will not affect the 5 volt voltage source, and also the current I will not affect the 5 volt voltage source. Similarly, you can consider this is 5 ampere current source. So here is, okay, this is R1, this is R2. So this is I2, and this is I1. Okay, I1. So this current I1 will not have impact on the 5 ampere current source, and this I2 will not affect the 5 ampere current source. Similarly, the voltage on R2, which is V1 and V2, okay, V1 and V2 will not affect the current, the 5 ampere current source. Okay, so they will generate energy by themselves. Okay, so when it comes to the dependent control sources, this is an active element of a circuit in which its value is controlled by another voltage across or current through an element in the circuit. Okay, so it is represented by a diamond-shaped symbol as shown below. Okay, the symbol for independent voltage or current source, it is a circle, whereas for the symbol for dependent voltage source or dependent current source, it is diamond-shaped. Diamond-shaped. It is active element, and its value will depends on values or voltage across or current through in the other elements. Okay, this is the dependent voltage source. This is, first we need to draw a diamond-shaped symbol so that we need to put the polarity. So this is the ideal dependent voltage source. This is ideal dependent voltage source, and similarly, this is the ideal current source. So this is it can be alpha, okay, alpha V or beta, okay, beta I, and this is the ideal current source. This can be gamma V or alpha I. Okay, alpha. Okay, so this is I. This is 1. So if V is equals to alpha V, so the unit of alpha is dimensionless, and this voltage is controlled by this voltage in the other circuit parts. Okay, and if V is equals to beta I, okay, beta I, so this current in the other circuit element will affect this voltage, and the unit of this beta is O. Okay, O. And when come to the dependent current source, when I is equals to, I mean, gamma V, okay, so this current will, I mean, this voltage in the circuit element will affect the current source, and the unit for gamma is 1 over O. Okay, when I is equals to alpha I, so the unit for alpha is dimensionless, and the current which is flowing through in the other circuit will affect this current. Okay, that's how we can consider the dependent voltage and dependent current source. So the types of dependent sources under the dependent voltage source, we have two very important sources, and under the dependent current source, we have two very important current sources. Okay, so voltage, this is voltage controlled voltage source, VCVS. This is voltage controlled voltage source. Okay, voltage source. So the symbol will be which is plus minus. This is alpha V. Okay, alpha V. So the second one, which is current controlled voltage source. The second one, which is CCVS. This is current controlled current source. Okay, so you'll have plus minus. So this is beta I. And for the dependent current source, you can consider the first one, current controlled current source. The first one, it is current controlled current source. So you can consider direction. So this is gamma I, and the second one, which is voltage controlled current source. So the same is, you'll have current direction. So you will have this. So this should be, it can be alpha V. Okay. So for this case, alpha is dimensionless. This is dimensionless. Okay. So this is I, this is I, this is V, and this one is V. For this case, beta is 1 over O, and this one is dimensionless. So the constant alpha, beta in the dependent voltage source, as well as the constant gamma and alpha in the dependent current source, we need to determine the unit. At what conditions they are dimensionless, at what condition when they are their own dimension. Okay, so that's all about for this session. We'll continue in the next video lecture. Please share, subscribe, and like the video lecture. Thank you very much.